continue with our third question. If you have watched the two videos previously recorded, you would have gone through the two questions that we answered. One was if monthly income is impacted by overtime an employee does. And the second question that we answered was for if monthly income is impacted by business travel. What we are going to do today is looking at the same data set where we have four variables: monthly income, overtime worked or not, business travel, this at three levels, and attrition. Looking at the same data set with these four variables, we're going to answer for the third question, which is attrition increasing because of low monthly income? Now, the very first step in solving any use case is to understand the problem correctly, because you need to define a very clear hypothesis statement. When we define hypothesis, the best way to make a clear null and the alternate hypothesis statements is to look at what is asked by the organization and start by writing alternate hypothesis first. Now, here the organization wants to understand if attrition is increasing because they are getting lower monthly income. This is the question. So, we start with writing this as our alternate hypothesis, and the alternate hypothesis would be population average monthly income of attrited employees is less than population average monthly income of existing employee. This is really what the organization is worried about. The organization wants to know if monthly income for attrited employees is really less than the monthly income of existing employee. And that is exactly what we have framed as part of our alternate hypothesis. The remaining, which is if population average monthly income of a tried employee is equal to population average monthly income of existing employee, will be captured as our null hypothesis. So in the null hypothesis, we have to ensure that there is an equality sign, which we have kept it here to say that population average monthly income of a traded employee is equal to average monthly income of existing employee. And the question that organization asked, is attrition impacted by low monthly income? We have captured that as alternate hypothesis. Hence, we have made a note that population average monthly income of a traded employee is less than the population average monthly income of existing employee. Now, as we know, attrition variable has two levels, yes and no. We are looking at two samples: monthly income for those employees who were attrition cases or who attrited, versus those employees who did not attrite. So these are the two samples or two groups for whom we have to analyze. And hence the type of test would be two sample t-test, assuming unequal variance again, because we have not looked at the variance in monthly income, and we're not going to check that because we are working with sample and not population. So it's safe to assume that they have unequal variance. The type of test is two sample t-test. However, it is one-tailed test. And it is one-tailed test because our alternate hypothesis has less than to be tested, which can be on the left side of the tail. So what really you can do is read the alternate hypothesis. If it has a less than comparison, the test would be one-tailed but left-tailed test, left side of the tail. If your alternate hypothesis has greater than sign, then again it is going to be one-tailed test but the right-tailed test. So less than means one-tailed on the left side of the tail. Let us see how we can solve this question in Excel. So this is our data set: monthly income, overtime, business travel, attrition. These are the four variables. I have captured the samples for attrition yes and attrition no here, which is literally the monthly income for this group and monthly income for attrition no group. And how I have captured is in the similar way we were able to capture for overtime and business travel. So looking at the two levels, you can filter and select the monthly income and copy paste in these columns. Now, Once we have the data ready, we can go ahead with our test. So I'll go to data, data analysis, and this time again we are going to do t-test to sample assuming unequal variances. We will put the selection range. So first is attrition yes, and for the second variable it is attrition no cases. We have labels in the first row. Our alpha is 0.05 as shared in the previous videos. We do not change this alpha unless and until it's shared specifically by the organization, or we think that the risk is too high. To take a risk of 5% will be compromising a lot, so we can reduce at that time, but safely for our organization purposes we can take it as 5%. The output, I want it in the new window apply, so I've selected this, and now I'll click on OK. So this is the result of t-test for two samples assuming unequal variances. If you look at the p-value for one tail, our test said that we have to do t-test for two samples, but it is going to be one tail test. The reason that we stated a little while back was because in our alternate hypothesis we had a less than symbol. So if it has a less than symbol in the alternate hypothesis, we will do a one tail test on the left side of the tail. And if you check this p-value, it is 2.21448 e to the power minus 13, which means 0.000. So you will shift this decimal point towards the left 13 times. So the value of p that you will get when you move this point or decimal 13 times towards left is 0.0000, and in many series it will be very, very close to a 0, which is less than 0.05 our hypothesized p, our alpha level. So if my actual p from the test is less than the alpha, if p is low, null will go. This is the rule, right? This is the rule that we followed in all our videos. If p is low, null will go. How you compare p is the p that you get from the test, you compare it with the p that you have taken to run the test, the alpha that you had taken, which is 0.05. Because this value is less than 0.05, we will say p is low and hence null will go. Our null hypothesis, let us flip back to it to PowerPoint where we have captured the null hypothesis, and this will go, which means we have to reject this null hypothesis. So we literally can reject that population average monthly income of a tried employee is equal to population average monthly income of existing employee, which means that they are not equal. We can infer that the monthly income of both the group is not equal. We will reject the null hypothesis. So what we can really recommend to the management is that there is sufficient evidence to prove that population average monthly income of attrited employees is not equal or differ from that of non-attrited or existing employees. So we can say that there is sufficient evidence to prove that population average monthly income of attrited employees is different than existing employees. Is different, or in fact in the alternate hypothesis we have taken lesser than, so that is what we can add here. There is sufficient evidence to prove that population average monthly income of a attrited employee is less than existing employee. Less than that of existing employees. This is a strong recommendation for the management, and when you share this with them, they will be able to understand that maybe the monthly income is the root cause of why people are leaving organization. And if they can control monthly income, if they can make the pay balance really competitive for all the existing employees, there may not be further attrition cases. They may be able to reduce attrition. So you can literally do t-test here and recommend to the organization this insight that you have just concluded basis your p-value when you did two sample t-test assuming unequal variances. This will give a very strong clue to the organization, and this is what the organizations are looking forward when they say that they need some analysis work, they need some insights and recommendation. So we have actually used Excel and tried to answer all the three questions for the organization. Likewise, there are many options in Excel that will help you perform similar statistical tests and more advanced versions of the test like multiple linear regression. And you'll be able to not only recommend but also give some information, some clue on what is happening between different variables. How are different variables related to each other? How can increase in one can cause decrease in another? In what ratio? And you can also look at it from the prediction perspective. So we will not talk about prediction at this point in time, but in the next video, I'll share how we can do regression in Excel. And when we do regression, I'll also share how you can look at the multi-collinearity issue. So all of the nitty-gritties I'll explain in successive videos. For now, this video will stop here, but we will again start with regression from our next video onwards. So thank you for watching. Stay tuned.